Hi, I'm the owner of a company leasing dark fibers to various service providers and companies across the country. Our customers want to load and secure traffic on our dark fiber networks using their own equipment. In the event of a cable or fiber failure, they require a very fast response even though we have no visibility on any active equipment. I gave the task to my engineering team to find a way to become more proactive, despite the lack of traffic status related data. We decided to put in place Expo's FiberGuardian test equipment to monitor all our critical routes 24/7. FiberGuardian is a no TDR-based test unit. It's plug and play, that is, it automatically defines, runs, and analyzes a series of OTDR acquisitions on multiple fibers, proactively logging events based on thresholds and giving us that one little step ahead that makes a difference. If an issue occurs, we immediately receive an alert with the precise fault location. With that solution, we were able to achieve a repair time of less than 2 hours. Let's peek further down in the network to see how the FiberGuardian fits in optically. The fiber cores to which we connect the FiberGuardians are either our maintenance or extra capacity fibers for surveillance of the cable. We also monitor the optical fibers being lit by our customers' equipment. To monitor the lit cores, we installed an Expo 24-channel test access module kit, which is essentially a set of 3-way optical multiplexers, passively coupling both traffic and OTDR signals together on the same fiber. The traffic comes in or out of a port on the left side. The corresponding port on the right side connects to the network. The OTDR signal input is at the rear on a pigtail connected to a FiberGuardian port. Now that everything is connected and traffic has been switched on, let's see how my colleague initiates the monitoring of one of these cores. Now let me show you how it works. To initiate monitoring on a port, I invoke the unit's hostname or IP address in my browser. I remotely connect to that unit. It's just like any other web-accessible server, router, or switch. I then log in securely. Everything is factory preset. I simply go to the Remote Test Unit menu and click on Detect. I then select the port I want to monitor, click Start, and I'm done. Now, we also opted for a software option called Fiber Test Insight. With it, the optical length of fault from FiberGuardian can be displayed onto a fiber network map. From the Activate Monitoring view, I drill down to the specific FiberGuardian unit I want to map a new route with. First, I go to the Routes menu and click on Use Bing Routing. Select the port. Select Edit. Then, turning to the map, zoom out and pinpoint the route's end. The software will trace the shortest path for traffic. I can move breakpoints to make it closer to the real-world situation. For more precision, for each cable span making up the route, I can create splices. I can adjust the proper OTDR span length recorded on the FiberGuardian unit. I can give it a name or more detailed information. I can add any slack loops and make sure the route length fits the OTDR trace length. Our system is now ready to alert our field technician in case of any network issue is detected. Oh, got an email from the Fiber Insight Test application. Got an image with the route and location of the fault, and a URL that takes me to my Google Map application. Here's a route. I'll hit Get Directions. Great, I can be there in less than 20 minutes. Let's go. Hey Jim, yeah, I've just done the repairs. Can you check on the FiberGuardian if everything is okay? Yep, hold on, I'm running an on-demand test. Okay. Oh, I can see from my FiberGuardian that the fiber is properly restored. Wow, thanks for fixing this so fast. Yeah, no problem. Yeah, you too. Bye-bye. Okay, I then navigate to the configuration menu, select the route or port. The test setup and query the unit to reset its OTDR baseline with the Renew button. Resuming fiber monitoring after repairs is done in one click. Taking the new OTDR reference or baseline data is done through a statistical analysis that X will call the learning phase. Reference trace is actually built from a certain number of acquisitions. The software sets and gradually narrows the fall detection thresholds wherever possible all along the route. The learning phase avoids false alarms as an alert is created only when the current value is higher or lower than the automatic thresholds that were set during the learning phase. The beauty of it? I don't need to set those values manually or even be an OTDR expert to put my RFTS up and running with the best threshold values. Investing in Expo's FiberGuardian proved to be the keystone of our support and maintenance operations. At the end of the day, we were able to divert resources from purely reactive support to a more diversified role including performance and quality improvements, something for which we never had time before.